Here we have AP calculus AB problem. Okay, let's go to the question. Evaluate limit x approaches 1 negative x positive ln x over 1 positive cosine pi x. Okay, we have to evaluate the given limit. Okay, let me do it by direct substitution. That is, I'm going to plug in the given limit 1 for x into the function over here. When I do so, I'm getting 1 negative 1 positive ln 1 divided by 1 positive cosine pi times 1. I just plugged in the given limit 1 for x over here. Okay, let me evaluate. So here 1 negative 1 will become 0. Okay, here we have natural logarithm of 1. In logarithm, if the argument is 1, then the value of the logarithm is 0. So it doesn't matter what type of logarithm we have, whether we have natural logarithm or common logarithm, whatever logarithm we have, if the argument of the logarithm is 1, the value of the logarithm is 0, then we get 0 over here. 1 positive cosine pi times 1 is just pi. Then we get 0 positive 0, we get 0 in numerator, 1, and the value of this cosine pi is negative 1, then we get 1 negative 1, then we get 0 divided by 1 negative 1 is 0. Actually, this is called indeterminate form. When I evaluate a particular limit, if I get 0 over 0, that is indeterminate form, we should not consider this one as a final answer. So what we need to do is, we have to do the possible simplification in the stuff we have over here. Otherwise, we have to use L'Hopital's rule. I don't think we'll be able to simplify the stuff we have over here. So what we can do is, we can use L'Hopital's rule. L'Hopital's rule means what we have to do is, in the given limit, we just have to find the derivative of the numerator and derivative of the denominator. And please remember, we should not use a coefficient rule. Just whatever stuff we have in numerator, we have to find derivative of this one. And the same thing, we have to find derivative of the denominator as it is. Let me write over here, limit x approaches 1. Since I'm using L'Hopital's rule, we have to find the derivative of the numerator over here. Since we have the limit for the variable x, we have to do derivative with respect to x. Okay, when I find derivative of this constant 1, it will become 0. We don't have to write that. When I find derivative of this negative x, it will become negative 1. Positive, when I find derivative of this ln x, is just 1 over x. Then we get, so when I find derivative of this 1, it will become 0. We don't have to write that. And when I find derivative of this cosine of pi x, it will become negative sine pi x. Okay, so far I have completed derivative only for the trigonometric function cosine. By chain rule, I have to further derivative of this pi x. When I find derivative of the further derivative of this pi x, so here pi is a constant and x is a variable. So when I find derivative, the constant which is multiplied by the variable to be kept as it is. And when I find derivative of this variable x, it will just become 1. So then I'm getting pi times 1 is pi. So the derivative by chain rule, when I do further derivative of this pi x, it just becomes pi. Then we get limit x approaches 1. Okay, now what we can do is, we can do possible simplification over here. So here we are adding an integer and a fraction. Whenever I do addition or subtraction between an integer and a fraction, I have to multiply the integer by the denominator of the fraction. Once I'm done with this multiplication, I can take this x as a common denominator. Okay, now let me multiply this negative 1 by this x. I'm getting negative x positive 1 over x, and in denominator, so we can write this pi in front of this sign. Then I'm getting negative pi times sine pi x. Now let me assume there is a 1 in denominator over here. Let me continue. Limit x approaches 1. Let me write this fraction as it is. It is a negative x positive 1 over x. And when I change this division as multiplication, I have to get reciprocal for this stuff over here. Okay, now let me change this division as multiplication and take reciprocal of this one. Then I'm getting 1 over negative pi times sine pi x. Okay, let me continue over here. Limit x approaches 1. Now we can multiply the numerator by numerator. When I multiply this negative x positive 1 by this one, still I'm getting the same stuff. That is negative x positive 1. Okay, when I multiply this x and negative pi times sine pi x, what I can write is a negative pi times x times sine pi x, because since pi is a constant, I write negative pi in front of everything. X is inserted between negative pi and sine pi x. Okay, that's all the simplification we can do over here. Now what we can do is, we can plug in the limit 1 for x over here. Okay, let me do it. Then I'm getting negative 1 positive 1 divided by negative pi times 1 times. So I just plugged in the given limit 1 for x over here and x over here. And when I plug in 1 for x over here, it will become pi times 1, that is just pi. Okay, in numerator, negative 1 positive 1 will become 0 divided by, and the value of sine pi is 0. 0 multiplied by everything will become 0. Okay, again I'm getting 0 over 0, that is the indeterminate form. So now what I have to do is, we have to use L'Hopital's rule again. There is no restriction of using L'Hopital's rule multiple times. So, okay, so to use L'Hopital's rule, we have to consider the step which comes right before where we have applied the limit. So, this is a step where we have applied the limit 1 for x. So, we have to consider this particular step to use L'Hopital's rule. Okay, now let me continue on the next page. So, here we have limit x approaches 1. Negative x positive 1 over negative pi times x times sine pi x. Okay, now we have to use L'Hopital's rule in this step, that is limit x approaches 1. We have to find the derivative of the numerator. When I find derivative of this numerator negative x positive 1, I'm just getting negative 1, because here when I find derivative of this negative x, it becomes negative 1. So we take negative sign as it is, and the derivative of x with respect to x is just 1, and the derivative of this positive 1 is 0. Okay, now let me consider the derivative of the denominator. Here, so this is a part which contains variable x, and this part is multiplied by the constant negative pi. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is, and I have to get the derivative of the variable. But here we have product of two variables. So one is x and other one is sine pi x. Okay, whenever I want to find derivative of the product of two variables, what I have to do is I have to use the product rule. That is, I have to keep the first variable as it is and get the derivative of the second variable, that is sine pi x prime. Okay, now I have to take positive sign. I have to take the derivative of the first variable and keep the second variable as it is. It is times sine pi x. Okay, let me continue. So limit x approaches 1. We have to take this negative 1 as it is. Then we get negative pi times x times. Okay, when I find derivative of this sine pi x, I am getting cosine pi x. By chain rule, when I do further derivative of this pi x, it will just become pi, okay, positive, and the derivative of this x with respect to x is just 1, that is 1 times sine pi x. Let me continue over here. So we get limit x approaches 1, and also here we can cancel this negative sign and negative sign. Then I'm getting 1 over pi times, and we can write this pi in front of this x over here. Then I'm getting pi times x times cosine pi x. Please remember, this is a variable x, it's not multiplication. Positive 1 times sine pi x is sine pi x. Okay, so I think that's all the simplification we can do over here. Now we can plug in the limit 1 for x over here. Then I'm getting 1 over pi times, so here pi times, and for this x we have to plug in the limit 1 cosine. When I plug in 1 for this x over here, pi times 1, it will become cosine pi positive sine. When I plug in x equals 1 over here, 1 times pi is just pi, that is sine pi. Okay, then we get 1 over pi times, so pi times 1 is just pi, and the value of cosine pi is negative 1, and the value of the sine pi is 0. So let me continue on the next page. We get 1 over pi times, okay, inside the square bracket we have pi times negative 1 is negative pi positive 0. This negative pi positive 0 can be written as just negative pi. Then we get 1 over pi times negative pi will become negative pi square. It can be written as a negative 1 over pi square. So the evaluation of the given limit is a negative 1 over pi square. Okay, let me go to the question. Okay, we find negative 1 over pi square in answer choice B. The correct answer choice for this question is B.